The world is currently undergoing a silent but massive transformation. In the fields of critical raw materials and water technologies, the industry is facing a new reality. The focus is shifting towards closing water and material loops in the raw materials sector and advancing environmental protection. Huge investments are being made. State-of-the-art electrodialysis and membrane systems are being installed to meet these environmental goals. On the hardware side, we have immense capacity. However, when we look at sector reports and data from EIT raw materials, we see a critical piece missing in the middle of this perfect picture. Welcome to the EDventure Podcast series. I am Eddie. Today, we will talk about how we combine the strong foundation provided by academic education with the field experience required by the industry. In other words, how we complete that missing link with the EDventure project. Let us summarize the situation. We have state-of-the-art machines and brilliant engineers raised in our universities who understand the science behind them perfectly. Our academic world delivers the mathematics, chemistry, and theory of this work exceptionally well. However, in complex technologies like electrodialysis, converting theory into practice is not always easy. Why? Because this is a scale and access problem. While universities often have smaller scale setups or pilot units, replicating the full complexity and operational demands of an industrial scale facility within a classroom is a significant challenge. Our students learn principles on paper, on blackboards, or at a laboratory scale. They know the movement of ions and the structure of membranes theoretically. But when it comes to going out into the field, there is a moment of hesitation in front of that massive machine. Because theoretical knowledge needs a space to transform into muscle memory and operational experience. This is where the challenge we call the experience paradox comes into play. In an industrial facility, it is very difficult to provide training while the production line is running. The cost of error is high, and the risks are significant. No business can risk its equipment and operations to say, "Come here and learn by trial and error." This is not a fair burden for either the business or the newly graduated engineer. So, how do we transform that valuable theoretical knowledge from the university without harming real-life experience in the factory? The answer is the EDventure project. EDventure builds a virtual bridge between our schools and the industry. Thanks to virtual reality technology, we bring those hard-to-reach massive facilities right to the students' feet, into their classrooms, and even into their homes. This is an approach that does not replace traditional education, but equips it with superpowers. Imagine this. A student listens to the ion exchange mechanism from their professor in class, learning the theory. Immediately after, they put on their VR headset and start walking inside the very topic they just listened to. In the world of EDventure, we offer our students the most valuable thing, a safe space for experience. Here, they can open and close valves, change pressure settings, or even accidentally crash the system. These mistakes, which could be disastrous in real life, turn into priceless learning moments in the EDventure simulation. The cost is zero, the gain is 100%. Moreover, this technology gives students a perspective they cannot see in books or physical laboratories: X-ray vision. In a real machine, processes happen behind closed doors, inside the stack. You cannot see them. But in the virtual environment, our students can make the machine transparent. They see with their own eyes how water is purified and how molecules separate. Abstract theory suddenly turns into concrete, living knowledge. In this way, the formulas, graphs, and diagrams they learned in school fall perfectly into place in their minds. Here, we can use that famous metaphor. The massive facilities built by the world are like Formula One cars. Our universities train excellent technical teams that understand how this vehicle works. EDventure, on the other hand, is the advanced simulator where those pilots practice for hours and memorize every curve before getting into the car. Our goal is to ensure that the engineer entering the factory does not have shaking hands. They should have the confidence to say, I learned this theory in school and I applied it in EDventure. Now I know exactly what to do. EDventure is a powerful vision of the future that carries education into the industry and the industry into education, built together with our partners. Today, we talked about how theoretical knowledge transforms into flawless practice in the virtual world. In the next episode, we will open the doors of this digital laboratory and take a closer look inside our modules. Until then, keep learning and keep exploring.